In this screencast, you're going to learn or review graphical presentation techniques for data. In particular, we're going to talk about univariate data and bivariate data. Univariate data is when we have only one measured quantity, and we've been talking primarily about univariate data in this course up until now. You're just interested in frequencies and probabilities. For example, we're measuring height and we're making a distribution, or we're interested in the probability of an event occurring. There's no correlations between different variables that can be made because it's just a single variable. We can put together density functions, but that just tells us probability, not correlations. We can visualize univariate data using stem and leaf diagrams, histograms and ogives, and box plots. And I'll explain each of these here in turn. For stem and leaf diagrams, we separate individual data into two parts. We have something known as a leaf, which is the rightmost digit, and we have the stem, which are the digits to the left of the leaf. For the data that I showed in the previous screencast on Old Faithful, the left here represents the stem, the middle section here represents the leaf. So if we took our data and we sorted it from low to high, this column here has our data sorted low to high. The leaf is just the rightmost digit. So on the first one, it's going to be a 3, second one 5, 8, 8, 9, 9, 9, and so on. The stem represents the digits to the left. Sometimes you'll see this just as 4, 5, 6, 7, 8, 9, 10, but sometimes you'll see it represented in terms of the tens here. If we put together all of the data, you can kind of see the distribution. It's almost like a histogram that's been turned on its side. So we list the stem values in ascending order in a vertical column. We record the leaf values beside the corresponding stem, forming lists to the right. And optionally, over here on the right, we can record the frequencies in the column. This is just the number of leaf items for each stem. So essentially, it's just a histogram turned on its side. Speaking of histogram, you guys have seen histograms before in this course. A histogram shows the distribution of data. There's a certain sweet spot for the number of bins. If you have too few bins, you're not going to be able to see a distribution in the data. If you have too many bins, then you're going to see just a bunch of tiny little bins, and you're not going to be able to show the distribution either. Let's go back to the Old Faithful data. I have created a histogram here, and I'll post this file on the course website. We have frequency as a function of bin center. And again, this is univariate because all we're looking at is the interval between times that Old Faithful erupts. If we look at the cumulative frequency, we can create a cumulative plot, and this is known as an ogive.
Ogive, ogive, ogive.
So here I've got a cumulative probability. You could also do cumulative frequency for an ogive, but it basically is a cumulative plot. And that's something that you haven't learned yet in the course. We can also visualize univariate data using something known as a box plot. And you're going to create a box plot by hand in an upcoming workshop. The box here shows the difference between the first quartile of our values and the third quartile. And this, by the way, is arranged on a linear scale. The median is also known as the second quartile. That's this line here. So the box kind of shows you how skewed the data is. The interquartile range is the difference between the third quartile and the first quartile. What we do is we extend 1.5 interquartile ranges from the third quartile and down from the first quartile. And these whiskers extend to the last data point within 1.5 interquartile ranges. So the very end of this whisker would be the last data point that is within 1.5 IQR, and same thing up here. Anything that lies outside of 1.5 IQR, which is also known as an inner fence, is denoted as an outlier, and that's what's denoted here by this asterisk. Anything that lies outside of 3 interquartile ranges in one way or another is oftentimes known as a severe outlier. You can generate these box plots in different software tools like Minitab. Let me show you real quick how we can do this in Excel. I've got a file called burritos on the course website. I've got burrito weights for 5 different restaurants in Boulder. This is real world data, by the way. A couple years ago, we collected burrito masses. And if I go here and I want to put all these on a single plot. We have different series. So they're different series, but they're the same variable, right? It's just weight. We can go up here to Insert, Recommended Charts, and go to All Charts, and go down here to a box and whisker. So sometimes it's known as a box and whisker plot. I can click OK. I'm just going to format this real quick. So I formatted that. The nice thing about a box and whisker plot, also known as a box plot, is you can easily compare on the same scale 4 different series here. Again, anything that has a skewed distribution, the median, this little line here, is slightly below center. And if we had outliers, we would see an outlier that would be above or below these whiskers. To visualize bivariate data, there's a couple tools that we can use. Bivariate data first is 2 measured quantities. You're interested in correlations between those measured quantities. We can visualize using scatter plots or column charts. A scatter plot, you essentially have a dependent variable on one axis, an independent variable on the other axis, and you're plotting pairs of data. So each of these red dots is a pair of data. This is generally used for time series data, continuous or non-categorical data, and you can show correlations between 2 variables. And again, the important thing is that you have paired data. Each point here represents some combination of the independent variable value and a dependent variable value. An example would be the high temperature as a function of the date. There's lots of other examples that you guys have undoubtedly been exposed to over the last couple years. You can plot 1 or more series on the same plot. This is known as multiple series. The x and y values of each series represent the same variable. It's just a different set of data. Multiple series are distinguished from each other using a legend. As an example, we could still be plotting temperature on the y-axis, date on the x-axis, but our 2 series could be the high temperature for that date and the low temperature for that date. Same variable, it's temperature, it's just a different series. When the dependent data of a series is different in nature, for example, it's different units, we can put this on the same plot, but we can distinguish it from the primary axis using something known as a secondary axis. For example, here we have high temperature, low temperature. Those are both temperature, so we plot those on the left axis, but we can add in a secondary axis over here for precipitation. Let's talk real quick about column charts. Column charts also display bivariate data. We have a dependent variable and an independent variable, generally used to visualize data in which the independent variable is categorical in nature and not continuous. Some examples would be if you had people, maybe you have different staff in your department and each person is making different sales each year. So the dependent variable would be the sales. The independent variable would be the different people. So those are categories. Maybe countries, departments of a store. By the way, time series data is much better presented on a scatter plot unless it's monthly, quarterly, or yearly data. As an example of a column chart, we could have a population as a function of the state. State is not continuous, it's categorical, and so that's better represented as a column chart. We can also put multiple series on a column chart. We have the state on the independent axis. We can plot population on the primary axis and area of that state on a secondary axis. Hopefully this screencast gives you an introduction to ways that we can visualize data.